So, properties of quadrilaterals on page 25. Okay? Quadrilaterals, any four-sided shape, any closed four-sided shape is a quadrilateral. We know that the sum of interior angles is always equal to 360 degrees. Always, always, no exceptions. So if you have something like that, it's not a rectangle, it's not a square, but it is a four-sided shape. It's still called a quadrilateral, okay? And we know that the angles inside, I'm making this up, so let's see, this is already 150. Oh yeah, this is 85, let's say. This is 125. So if I were to go 70 plus 80 plus 85 plus 125, 25. That is equal to 360 degrees, always. Which means if you have three angles, you can find the fourth one no problem, right? It's always the case. So here we have, there are 7 names that we have for quadrilaterals. Like you're supposed to know what the properties of them. Okay, so here it is. Here are your 7 names. Okay, so quadrilaterals is the name for all of them. If you go to the left here, you've got the parallelogram. That's 1, rectangle 2, 3, 4. So there's 4 shapes on the left side of this. There's the single shape along the middle, kite. This is a very unique shape. I should write down not a diamond. You know why? Because almost every exam, this shape shows up and they ask my students, what is this shape called? 99% of the time they say kite, and then one student has to say diamond. I'm like, we never talked about diamonds. It's not a diamond, it's a kite. Trapezoid, so 1, 2, 3, 4, right? 5, 6, and you're like, wait a minute, 7, 8, what's going on there? I would not count that as I would just say 6, 7 for your Thursday. The trapezoid breaks down into 2 separate ones, right? So you can call this 8 if you want, but I'm going to say there are 7 distinct shapes, okay? Here's something I'm going to say about the left side, okay? Go ahead. Okay, guys, you wanna know this part. All these 4 here, all of them have this in common. Watch this. The top and the bottom side, they all measure the same. Okay? Sorry about that. We know that the side lengths on the sides, these are going to be the same. Same here. So we've got 2 pairs of congruent sides. Now, it's still true for rhombus and square that these 2 are the same. So are these 2. However, there's something, what do we know about a square? All 4 sides are actually the same. It's actually very specific. A rhombus is related to the square in this sense, that all 4 sides are also the same. But it's a slanted square. I think of a rhombus as a slanted square. Okay. So let's write this down. No, we're going to go to 26 to make. I want to minimize the amount of copying you have to do. I have a lot of stuff here, a lot of notes, but we're going to just stick with one at a time here. So here's where colors are going to come in. Maybe not right away, but as soon as I transition. So a parallelogram, what does it have? 2 pairs of parallel sides. And from now on, in terms of parallel, I'm just going to use that symbol. Okay, I'm not going to actually write out parallel anymore. I'm going to use that symbol. It's got two pairs of congruent sides. Instead of congruent, I'm going to use this equal sign with the third little squiggly line on top. It's got two pairs of congruent angles and the last one is diagonals bisect. Anybody know what that means? Diagonals bisect. They cut each other in half. So you can say, hey, you want to bisect this bill, right? You want to split the bill. Anyways, that's what I have to say about that. And this is something that makes a parallelogram. This is kind of like the OG of all these four that you see on this page. So this is true for all. True for all of these, okay? All four. It's true for all four on this page, okay? Just so you understand that. And here's where my colors are going to come in. Maybe it's going to get a little bit too crazy, but try to make it work. When I say two pairs of congruent angles, I'm going to give this a color. What I mean by that is that this angle and this angle are going to be the same. So if you know that this is 50, this is 50. Right? Actually, it's an obtuse angle, right? If this is 100, this is 100. If this is if you know the measurement of this, you actually know the measurement of that angle up there. Okay. And then for diagonals, I'm going to use this color. Diagonals cut across the shape from corner to corner. So you go from here to there, and from here to here. And they cut each other in half, okay? What does that mean? It means that this stretch and this stretch, like at that point of intersection, if you took this diagonal, it would cut in half. Like from this center to this corner would be the same as from the center to that corner. And so would this one here. However, the diagonals are not the same length, guys. Okay, they're different. There's the long diagonal and there's a short diagonal. So I will make a little note here. Long diagonal. And this is the short diagonal. And so what a lot of my students do is they leave this for the end just before the exam, and then they try to like cram in as much of this as they can. But in the meantime, I wouldn't use up too much of my study sheet with all of this, okay? Okay, I want to talk about parallel sides. Parallel sides, in terms of markings, we go arrowhead like this, and we put an arrowhead up there as well. So you're telling me that these run alongside each other. They never cut, they never touch. Okay? That's the tragedy of parallel sides. They have so much in common, but they'll never meet. Okay? Walk, walk, walk. Okay, and then this side is parallel to that side. So these ones, if we extended those sides, they would never meet. Okay, so that's something that you need to know. All right, let's keep going. How's a rectangle different than this? What's unique about a rectangle? All of these things are true, but what's very unique about a rectangle? They have 90s in all four corners, yes. All angles are equal to 90 degrees. That's very unique about it. Okay. Diagonals are equal. Would that make sense to you if I asked you, hey, like, what is the distance from this corner to this corner? It would be exactly the same as from that corner to that corner. It's because it's not slanted. Okay, so diagonals. So this is very specific. Okay, specific to rectangles. So all of these are true. Mr. Jackson, you're saying that all of these are still true? Yes. Do you have two pairs of parallel sides here? Yes, you do. Two pairs of congruent sides? Yes, you do. These are the same. These are the same. You have two pairs of equal angles? Yes, these are the same, right? So are these two. They happen to all be the same, but this is still true about them. Diagonals bisect? You bet, right? However, I will actually ask you to do that here. This diagonal and this diagonal are exactly the same. So watch what's special about this is that all these segments that are created, they are actually all the same. From the center to each corner, they're all exactly the same. That was not the case about a parallelogram. Okay, that's specific about a rectangle. So now let's go to the rhombus. Rhombus and square are also related. What is special about a rhombus is that diagonals are perpendiculars. What does perpendicular mean? They cross each other at a 90, right? That's what it means. Okay, meet at 90 degrees. That is very, very unique to the rhombus. So I'm going to give it the same color as I've been giving the diagonals, orange. And you cross them and then just make a 90 at the center there. That's only the rhombus so far will have that property. And another thing is that all sides are equal. So you can go ahead and just make one of these. It's hard to see, but do you think the diagonals are the same in length? If you have a ruler, you're saying no? If you have a ruler, you can actually check that for yourself. So watch this. This is going to be 49 millimeters. And this one is 34. Okay? So like if you think of pinching this, right, this is going to be the long diagonal. This is going to be, so anything that's slanted, guys, slanted shapes, the diagonals are not the same in length. Okay, so you've got your long diagonal, short diagonal. So If it's slanted, don't think that they're the same, okay? They're just not. So what about the square? What's so special about the square? All sides are equal, just like before. I don't think anybody's surprised by that. Diagonals are perpendicular as well. Okay, so that's, if you want the symbol for perpendicular, you can just say, we do one of these. Okay, that's the symbol for perpendicular. And diagonals are equal as well. So here's my, I'm going to talk about diagonals. So they are equal in length, and they also meet at a 90. And a lot of these things you already know. Okay. So this is, yeah, these are, just hang in there, okay? I want to finish this today. This is what I need you to be able to do. If the question says, the problem says, hey, look at the rhombus below. If this is 5 centimeters, don't copy this down right now. If this is 5 centimeters, what's this side? They would expect you to know that that's 5, okay? Oh, another one right here, watch this. If I tell you that from here to here is 2, then how long is this stretch going to be? Yes. How do you know that? I've told you, right, that the diagonals bisect. They cut each other in half. It's true for all of these. So these are things that they would expect you to know. And some of you would probably just instinctively say that, but you need to know for sure. Okay, so I'm going to erase this because I just made that up, right? Okay. Okay, let's keep going. There's a right trapezoid and the isosceles trapezoid. The right trapezoid is a very boring shape, to be honest. This is what you need to know. It's got two right angles. They're right here, the 90s. That's what a right trapezoid is. It's got two right triangles, one pair of parallel sides. You know that symbol, right? It's just telling you that this side is the same as that, is parallel to that side. Other than that, there's nothing special about it. This one, the isosceles trapezoid, think of it this way, guys. Remember an isosceles triangle? Imagine that the top here has been chopped off, like this part is missing, and they just left you with that. So these two sides are still the same. So we're going to go mark, mark. Okay. So one pair of equal sides. It's got one pair of parallel sides, the top and the bottom, right? You can go arrowhead, arrowhead there. The diagonals are equal as well, but they don't bisect. That's important to know, that the diagonals are equal, but they don't cut each other in half. They don't meet at a 90, none of that, okay? I'm going to give it that orange color. Oops, sorry about that. We're almost done. Okay, but they don't cut each other in half. And last but not least is the kite. Here's the kite. Diagonals. What does that mean? Diagonals are perpendicular. Okay? We're almost done, guys. So that's what makes that's the common thing about a kite and the rhombus or the square is that the diagonals meet at a 90. Okay? You've got two pairs of equal sides. Which is the first pair you think is going to be the same? This one and this one, right? And then this one and this one. Short diagonal bisects. What do you mean short diagonal? Which one, Mr. Dirksen? This one here. This one here will bisect. So I will highlight that. There's a long and a short diagonal. So it's that one right there. Cuts in half. So if it's across 10, then we know that half of it is 5, half of it is 5. That's what they're telling us. I think we're good. One pair of equal angles. I will give you a color for that. I'm going to use green. It's this one and this one that are the same.